Hi, thanks for joining my Day 4 daily recap for CKA Exam Prep. As per usual, this week I've been having a daily recap where I have kind of like a question answer format to talk about what I've learned this week. And today we're going to continue scheduling. Yesterday we also had scheduling, today we're going to continue. So, what happens when a pod exceeds its memory versus CPU limit? When you have a memory exceeds on a pod, you have an event where you'll have an error that says killed or out of memory killed. Now, when the pod is killed, it is restarted. And of course, if you have a memory leak or your pod just needs more memory, then you would have to adjust that. Now, in contrast, when you have a CPU limit exceeds, well, the pod is actually throttled rather than killed. Now, what's the difference between a resource request and a limit? Requests drive scheduling decisions, rather limits cap runtime consumption. What does a daemon set guarantee? One pod instance on every node. New nodes get the pod automatically. So what this means is if you scale up your cluster, Kubernetes cluster, say 1, 2, 3 n nodes, then each of the nodes in your cluster, new ones that you've expanded to, will have the DaemonSet pod. Now, in contrast, if you scale down your cluster, that will not happen. What will happen is the pods just get eliminated. They won't get rescheduled to a different node. So how does a daemon set differ from deployment and scheduling? It bypasses Kube Scheduler and places pods directly via the daemon set controller. Now, what manages a static pod and how do you permanently delete one? The kubelet manages it from a local manifest file, specifically in etc kubernetes slash manifest, or etc slash kubernetes slash manifest. And to permanently delete them, you need to delete the actual manifest YAML file on disk. If you attempt to do a kubectl delete pod, what will happen is this kubelet will just restart it. So really, you have to delete the YAML file or move it out of that directly in order for kubelet to not to restart it and remove the pod. Now, why are control plane components run as static pods? The kubelet can start them before the API server exists, enabling bootstrap. So think of it like this: a circular dependency issue, right? You're trying to bootstrap a Kubernetes cluster. You don't necessarily have all the components started, right? So first thing you have is kubelet. Kubelet then allows you to define your control plane components as manifest files in the path that we mentioned earlier, and it will monitor that path, start your components, and thus enabling the bootstrap. So that's why the control plane components are run as static pods. Now, that's all I have for day 4. Thank you for everything. See you in the next one. Take care.